Good afternoon. Today we are going to see one problem that is of cantilever beam, and that is last year problem, July 2019. That was the first paper that is based on 2019 pattern. So we have this paper that is 2019 pattern. Question: we have cantilever reinforced concrete floor beam with the following data: center of span 2.5 meter, width of supporting column 450, beam width 230, working load is given 20, inclusive of self weight, and working live load is 18. Materials we have M25 and FE 500. I have actually now solved this problem. This already I solved it. Instead of this M25, I have taken it as M20, and FE 500, I have taken it as 415. Actually, I have solved this problem, but that materials I kept M20 and FE 415. The design longitudinal reinforcement with curtailment and shear reinforcement. Show details of reinforcement, use LSL. Only this was not taken. Values are taken M20 and FE 415. So we have this problem, and you can see here I have taken these values M20 and FE415. And the whole problem was solved, so I will not revise it again. So now effective span. So you can see this till center of span value is given L effect 2.5 meter. So I will consider it as 2.5 meter, and after depth calculation, we will again check it. Then we have L effective upon D, 7 into modification factor, this 7 because we have cantilever. For cantilever, we have this value as 7. So let us, we will assume that modification factor, we will consider it as actually 1 we have taken. So we have taken 1, and percentage of steel we are assuming greater than 1. And when it is actually greater than when it is go towards or beyond 1, then that value again reduced by 1. So here we will consider modification factor as 1, and from this we will get value of D 357.14. So now we will have beams, therefore we will put effective cover, that is 40 millimeters, and then we have overall depth that is equal to 397.14 millimeters. So we will round up it, and we have this as 400 millimeters. So my D becomes 360, that is 400 minus effective cover as 40 millimeters. Now we have this clause for cantilever, that is the effective length of cantilever shall be taken as its length to the face of the support plus half the effective depth. Except that is we do not have continuous beam, directly is given. So we will take it as half the effective depth, but that is from face of the support. So we have clear span plus D by 2 as per this clause. So now we have to subtract half the support because it is given till the center of the support, and then we will get L effective as 2455 millimeter. Then we have load calculations. Load are given actually. Dead load is given 20 kilonewton per meter, and this is given inclusive of self weight. So we have taken this total value, that is of dead load 20 kilonewton per meter, live load 18 kilonewton per meter. Both these values are given. Actually, these values are very large. If we will talk about cantilever beam, maybe question was of simply supported, and only the change made was cantilever beam instead of simply supported. So we are going to get this value so much high. So actually this step is not there. So we do not have this step. So now we have to go, that is total load, that is 20 plus 18, and we have this value, that is 38 kilonewton per meter. So knowing this value, we will make it factorized. So multiplied by 1.5 gives us 57 kilonewton per meter. Now we will go shear force and bending moment as cantilever beam is there. So VU directly equal to W into L effective. And we will get this value 139.94 kilonewton. Because if you remember in cantilever beam, we have one end fixed, other is cantilever. So whatever reaction we have, that is total load acting on it. So we have this will be total load. And this load that is given 57 kilonewton per meter, and this is given 2.455, and then we will get it as 139.94 kilonewton. Bending moment we will get 171.77 kilonewton meter, and then we will go next step. We will find MU limit. Now see, bending moment is very large, and as bending moment is very large, so this beam we have definitely as doubly reinforced. And therefore we have to go for MU limit. So you can have the check for bending, and your check depth will not be satisfied, and then you have to go for W. So whenever we have W, we can go step 5 as MU limit, and from MU limit we will get value. So these are design constants, and RU max we will have 2.76. So knowing this value, we can find MU limit, and we will get MU limit 2.76 BD square will be 82.27 kilonewton meter, which is less than 171.77 kilonewton meter. And as it is less than MU limit, so we have to design this beam as doubly reinforced section. And therefore, I have not taken this check depth from bending moment, because that will not be satisfied. And then we have to go doubly reinforced section. So as bending moment for cantilever is very large, that is 171.77. If we will see this 2.5 meter, so it will go greater than 8 feet. And this long cantilever that is generally not provided, very rare case we will go for this. Now we will go main reinforcement. Actually, we have here only main reinforcement. So AST1 now we will have MU limit, because we know we have doubly reinforced beams, and there if we will go, then you will see these formulas. Now I will not repeat this one. So we will get AST1 from MU limit upon 0.87 FY and these values, and substituting all these values, we will get value of AST1 792.78. This is 0.42 into XU max, because whenever we will design, then we have to go for balance section, and we have this value that is 0.48 into D, and D we have 360, and from this we got this value 172.8. Now AST1 we got at 792.78 mm square. Then AST2 we know this again MU of minus MU limit we can say divided by 0.87 FYD minus D dash. Now from this we will get value of AST2, and then we will find value of AST 1576.09 millimeters square. Now if we will go for 28 mm diameter bar, then this value comes actually 2.55. If I will go for 25, then that value goes 4, and area of steel provided will be very large. So instead of this, I have considered this as 2 bars of 25 and 1 bar of 28 millimeters, which will give me AST provided as 1597.59, which will be close to AST required. Now this is AST required 1576.09 mm square. So our requirement is satisfied. Now ASC we can find, for which we have to find FSC. For FSC I have to find epsilon SC, and epsilon SC we will have 40 upon, this is again DC, and this will be XU max, already we have seen. From this I will get value of epsilon SC 0.00269. We have these two values 0.00241, 342.8 and 0.00276. We have 351.8, and by interpolation we will have this FSC 350 Newton per mm square. Substitute all values in this equation, we will get value of ASC and that is 799.11 millimeter. So we will go this number of bars by providing 25 millimeters as 1.63. So we will provide 2 bars of 25 millimeter as tension reinforcement. Now after this, we have to go for check for deflection. And for this, we have to find percentage reinforcement. And we have that as 1.92. And for this percent reinforcement, if we will go to figure 4, we will have modification factor as 1. And then by substituting this, now L effective, we have calculated 2455 upon 7 into 1, we have 350.71, which is less than 360. This is D provided. So our check for deflection also satisfied. And now we will go for check for shear, or we can say shear reinforcement. So we have this step, that is shear reinforcement. Shear reinforcement. Now steel available at support, we have full 1597.49, which is 2 bars of 25 plus 1 bar of 28. And VUC, we have tau CBD. Now we have percentage of steel 0.75, for which we have tau C 0.56, and for 1% 0.6. And by interpolation, we will get this value for 0.92 as 0.59 Newton per mm square. Now substituting these values in VUC, we will get 48.85 kilonewton. Actually is much less than 139.94 kilonewton. If we will go for minimum shear reinforcement, then we have 0.4 BD, and this value we will get as 33.12 kilonewton. So we will get shear resistance of member with minimum shear reinforcement, and that we will get it as 81.97 kilonewton, again less than 139.94 kilonewton. And therefore we have to go for design shear reinforcement. Now we will assume 6 mm two-legged stirrup of grade FE 415. So ASV we have 2 into 28.27, and that is 56.54 mm square. Then VUS we will have 139.94 minus. Now we have VUC 48.85, this value VUC. And we have this VUS 91.09. And then from this we can find value of S. We will have 80.68 millimeters, and we will provide 6 mm two-leg stirrups at 80 mm center to center. So now we can have this reinforcement detail. We have at top 2 bars of 25, 1 bar of 28, because in cantilever beam, we have tension at top and we have compression at bottom. So tension, compression. And therefore this will be AST provided. And then we have at bottom, that is ASC. 2 bars of 25 mm. And then we have this will be cross section. If we will take cross section over here, then we have this will be cross section. And then in this, we have this bar is 28, these 2 bars, we have 25, we have these 2 bars also 25, and we have these stirrups, that is 2-legged 6 mm at 80 center to center. If we will go higher side, if we will take 8 mm, then you have this value, that is of spacing, that will be increased. Now I have not gone to curtailment, because in this case, whenever we will go for curtailment, then we have to think of both. We have to think of top reinforcement also, and we have to think of bottom reinforcement, and that becomes again lengthy. So I skip that one. So in exam also, you can try this. You have to consider 50% steel that is curtailed, and for 50% you have to find out moment of resistance, and that moment of resistance actually you have to equate that is with bending moment, and from this you will get it as WL square by 2. If I will go for this one, then again that video will be lengthy. This you can do easily. We have actually around 1600 mm square steel available. That is at end. So we can curtail 50%. So therefore AST available will be 800 mm. And then we can have MR, that is equal to 0.87 Fy is 415, AST is 800 in bracket D minus 0.42 XU. Now, again, you have to go because as doubly is there, so it becomes little bit, we can say lengthy, because now we have to again add, that is 50% curtailment of compression reinforcement. And actually in doubly, we avoid curtailment and we will keep as it is. So now in exam that was asked, so you have to go for this one. I will skip that step. Now I will stop here only. So thank you.